Alright, this is one I wanted to do because I was watching a video where this was brought up, and I was just like, oh my gosh, maybe I am right. It's like, um, yeah. And so, previously I made a talk about how um, I think that, based off the fact that our planet looks flat but isn't, that could then be taken to our universe looks flat but it isn't, right? And I said, well, if it's not flat, it's probably, rounded. Oh, hold on. Forgot to turn that off. And so, in theory, right, I was looking at the horizon, right? I had like my color gradients, and blue was at the top, and I had theorized, hey, maybe, just maybe, right, the galaxies that are super far away are actually blue. Like the farthest galaxies away would appear blue to us, right? And so I put that out there, right, as a potential thing. And I was like, I mean, it would be hard for us to tell. Like, I don't know how we would really know. And then I saw this video talking about this study where they're looking at galaxies in the distance, right? And they're doing this study for dark matter, right? And they're looking for dark matter and kind of observing how galaxies form and how like dark matter like shows up in these universes and stuff, right? And what they found is that the older universes tend to have, I'm not going to say this word for word, but you can kind of look into this more to get a better understanding of what I'm talking about here. I'm just giving the cliff notes on this, right? But basically, larger, older universes tend to have more dark matter in them. Younger, smaller universes have less dark matter. And this makes sense. It goes along with my theory that, mass goes from mass is the kind of transition state, and energy is going from dark energy into mass and then into dark matter, right? And so it would make sense that places where there's been mass for longer periods and more mass for longer periods should have more dark matter because more dark matter has been converted, right? So to me, that also points to that, but that's not what I'm trying to talk about here. You don't need to believe any of that to go along, to follow my reasoning with this, because what they found while they were doing these studies, right, is that there's these galaxies called blue dwarf galaxies, which I didn't know anything about this until I was listening to this. But there's, blue dwarf galaxies, and basically these blue dwarf galaxies are small, like low mass galaxies that I believe they consider to be relatively young, right? And so they look at these galaxies, and the dark matter, like, values that they're getting from however they do their analysis, right, is coming up completely different than what they would expect, right? It's coming up as more of this older it's following the older, more mass galaxies, like levels. It behaves as if it is an old galaxy with a lot of mass, even though it is a relatively young galaxy with low mass, right? So it makes no sense. Why would it do this? That's not what we think dark matter should do at all. That's not what we see everywhere else. Why is it with these weird blue dwarfs galaxies that we notice this? And to my understanding, it's only with these blue dwarf galaxies. I don't know for certain. I haven't done a ton of research into this, but it just, all right, I'm biased. All right, I'm biased. I believe it because it works. All right. I'll admit it. Right. And so the thing is that it makes a lot of sense when you think about maybe these blue dwarf galaxies appear to have low mass and, are blue shifted, not because they're like this young, like, galaxy or whatever, but they have low mass because only a small amount of the light and energy, basically we can tell the mass of these galaxies based off of the light that gets back to us, is my understanding of it. Maybe that's not exactly it, maybe it's a lot more technical than that, but to my understanding, the only way we know that they're there is because we can see them for the most part, right? Maybe like gravity waves could be a thing, but at that distance, I doubt it. And so, we're looking out, and whatever is making it to our, basically telescopes, really, not our eyes. We're not seeing these things, but our telescopes are picking up this radiation, and then using that based off of the radiation that they get, they can kind of boop, 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 get some numbers out. I don't know all the technicalities, but basically they can go, oh, well, based off of this amount of energy coming from here, we can assume this amount of mass, or something along those lines, right? But if you're looking at something that's really far away, a lot of that energy is being lost. It's not making it all the way to you, right? So you're only getting a limited amount of the mass that's actually there, and so it appears to have low mass, right? But it also seems blue shifted because it's just so far away, and our universe is actually curved and is potentially globe shaped. I mean, it's not a guarantee that it's globe shaped, I guess, because it could just be like, I don't know, curved, just slightly curved. I don't know. I feel like it makes more sense that if it's curved at all, it probably is curved all the way around. But I have no proof for this, This is just my theory here. But because it's so far away that it seems blue shifted, and because there's nothing in the way to block its light, there's nothing in its way to block its view, right? We don't get a lot of these because, certain criteria has to be met. Like, imagine how many galaxies and how many stars and everything is out there in space in between, all of these other stars and galaxies out in space, right? So it's very unlikely that they don't get, blocked out by something else. But when they don't, then we get these, blue shifted, small, low mass galaxies that are very far away, that the light is kind of getting bent in a weird way. I went over this. It's hard to explain because it's getting bent as if we have a horizon, even though we don't have a horizon in the same way we do on Earth. I'm not going to get into specifics of it. Basically, I believe that the universe is curved, right? And so the only way we would be able to tell, hey, is that really far away or not, right, is based off if it's dark. I don't know how I don't know the specifics of how they get this reading for the dark matter, but it seems to be accurate because they're getting a reading that they don't expect, right? And it matches up with my prediction. It matches up with my theory. It's the smoking gun of how you would predict. Oh, or how you could tell, oh, that's farther, right? That's farther away because it's blue shifted, but it has high dark matter, right? Okay, well, in order for it to have high dark matter, it must be an older universe. In order for it to be an older universe, it has to be farther away, right? And so we get to this point now where it's not just that we're going to realize that it's not just, oh, things get red, and then we can't see them anymore. No, it's that we can see universes even farther away. They actually get a higher they get a higher wavelength, because the wavelength that they were actually being initially shot out at could have been ultraviolet or something even higher than that, right? But after traveling that distance, it is now in the blue wave spectrum for us, right? So technically it is getting redshifted, but what it was redshifted from, right, is just a way higher energy than visible light, right? And I don't know what these universes actually, or these galaxies look like, right? But I was just really excited to talk about this because I listened to this video and I would just like kind of like was like my jaw dropped because I was like, wait a minute, that makes complete sense. like like it was one of those things where I thought there would never be any way for me to figure out if I was right about that. And then like a few weeks later, a video comes out about like a study on it, and I was like, no way, no way. Okay, yeah, but yeah, I don't know. Basically, what I wanted to say is that um, we should look into that connection and see if I'm actually right about this or if I'm just jumping the gun on this and, maybe the data is incorrect, which it could be. I don't know. I'm definitely not an expert on this, but I just wanted to put it out there because, I listened to it and then I was like, oh my gosh. And I added like the video to my playlist of videos that, are evidence towards my theories. And then I never wrote any note down about it to talk about it. And I was thinking about it. I'm like, I should say something. I gotta say something, right? Because I'm right. Right? We gotta flex. Yeah. But I think that's all. So, peace out.